Hi everyone, my name is Elvira Rakova, and today I would like to show you a very typical example of the engineering task for compressed air auditors, designers, and users, basically for everyone, compressor suppliers as well. I recently got a project where we had to calculate the required pressure levels at the compressor room as well as check the design that was already established by the customer, and as well as to understand what is the required flow rate to operate this system. The system is the ceramic plant. What we got was the information on the general consumers, machines, tubes, diameters, tubes length, and as well as not so much information on the compressor. We had to choose the correct one for this application. So now I would like to show you how we solve this problem with the Easycast, and also you also can do similar project by yourself. So first of all, it took quite time, maybe around 6 to 7 hours, actually, to create this design in Easycast. However, I think it's not very long time in comparison to other projects. So here what we did, as you saw before, basically we just analyzed the design of the system. I'm not gonna go into the compressor room and show you an example of the calculation now of the air reservoir, dryer, filter, and the regulators that also cause pressure drops. It was basically the idea to calculate the required flows and pressures before the compressor room, so before the dryer. These balls, they represent the consumers. So here you can find them in the basic elements, and here we have the element called consumer, and you parameterize it by the required flow and required pressure levels. So this we got from the customer. Of course, we also have the tube diameters. You can choose it from the catalog here. You can also parameterize it yourself, length and tube diameter. Then another important thing to remember is that we put the input parameters such as pressure at the compressor. Again, it's not the required pressure at the compressor, it's rather the idea of the compressed air cost at this pressure level. How many hours per day, for example, let's say 24 days per year, 240 it works. The ambient pressure, because we also can calculate it below the water surface, so maybe on other planets, and carbon intensity if you are interested in this. So you can here click on this link and check the map and put the coefficient for that. So after we press on calculate, we can see our system. This sign means that there is something wrong with the component, and I'll explain you what is wrong now. So if you go into the sign of the compressor, you can see the pressure, the output pressure, the flow rate, and as well as the CO2 emission coefficients and compressed air cost. And here you can see, here we need the 6 bar, the pressure, required pressure here, and here we have 8.5, meaning that the pressure drop is about 2.5 bar. So the pressure drop calculation is not trivial as you could think. So it's based on the ISO 6358, and it's an iterative process. So it's a very long equation to calculate the pressure drop. So it calculates for every diameter, for every step, like every millimeter step, and then it gives us the pressure drop. So it's iterative process. And pressure drop here, it is the optimization criteria. For example, if I want to have the value below half a bar, for example 0.2 bar, so I just press here on calculate, and now you see the program shows me more components. After this, it suggests me the pipe diameter, the minimum internal pipe diameter, to have the pressure drops no lower than no higher, sorry, than 0.2 bar, and then you can just choose it and choose it from the catalog, from the database of the catalog that is available here in this version, or you have your own database for that. You change it, and then you can see that the parameterize it also yourself, make it pretty to rotate it, and now you can see that the pressure drop is low because the tube is quite big. One by one, Before optimizing everything, I always recommend to copy the system, so you can use it in the same window. You can also use the C button to copy the window. And here I have already the other optimized. I already replaced all the components, and here you can see now I have the overall system pressure drop about zero point 0.4. That it's better than 2.5. The compressed air costs are also lower. And here you see it also recalculates new compressed air cost depending on the pressure level. So it's also iterative. What the before was 0.03 at the beginning. If we have higher at 0.033 per cubic meter, and here it's 0.028. This is the new recalculation of compressed air cost. And here you have already better designed system. In terms of time, it took about 1 day to calculate the full one day to put this design into the program. So maybe like 6 hours, like one working day. And you saw it's about 30 minutes, 1 hour actually to optimize components. You can also include other components such as filters, regulators. I mean, you have to include it. This was just the understanding before the compressor room, but we have many other restrictive components, filters, regulators, dryers, of course, and air reservoir that also has a certain pressure drop that also has to be considered in the calculations. But this is all up to you how detailed is going to be. I leave the link for the model so you can download it, as well as a link to download our software. The software is for free, the full version with all the functionality. However, we have also subscriptions for specific projects that we can support you, or also subscriptions for certain database of components. May it be tubes, may it be special cylinders, nozzles, or compressors. And I hope to see you soon in No Boring Pneumatic channel. Thank you.